Okay, hello everyone. Uh, okay, I'm so happy and honored to be here. And congratulations to the organizers and the volunteers of this great event. I also feel so blessed because I see here current and ex-beloved colleges. Thank you so much for being here and support me. I'm still stressed. I'm Vassilis Petrou, technical lead at Chubb. I have totally about 18 years experience in IT. The first years I worked as a software developer, working for some language that you're gonna say, wow, well, that was COBOL. And I also worked with PHP and some .NET. And then I turned to test automation, where I actually tried to build some, let's say, legacy on this part. And I'm very happy because I see very people here working together on that part, building test automation architectures and such stuff. I also worked as a full stack developer with Java, with Angular, Spring Boot, Java Enterprise Edition, and various technologies. So you hear before I spoke about COBOL, and this is actually has to do with legacy. This has to do with a need that many companies have to modernize their applications, their software. So this presentation has to do with modernization strategies that we can go on. So when we hear the word legacy, if I say, for example, to Fotis, you are legacy, it's cool. We like it because I'm powerful, I'm legacy, you know. Also in cinema, Born Legacy, it's a great movie, it's something good. But what happens to software? When the software will say that it's a legacy, it's something, you know, that is an outdated software, is there for years, and please don't touch it or don't change it because it's so sensible, you know, and it's so possible to have bad circumstances. So we are not so able to grow, to make it bigger. So we might wonder who has a legacy system? Is it so often? And yeah, 80% of the world systems are legacy. And about 200 billion lines of legacy code are still in use, and about 75% of financial institutions in Europe are using outdated systems for core businesses. It's okay, you know, it's okay. We understand that it's indeed so sensible to touch them. It's difficult to put new things there. It's difficult to adapt old things to old technologies. So there are some driving forces to tell us that we need to modernize our software. And this excuses that we lack of flexibility when we have a legacy application. And there are high cost of maintenance and change. There are tech stacks there, Java 8, for example, which is end of life. People with relevant skills are scarce, and integrations are difficult. It's okay to fail, because you know the real statistics for those who tried modernization to their softwares is not so positive, but we must keep believing on that. So legacy modernization success rate is about 24 to 39%. 1 in 6 projects result in black swan, which is a very interesting statistic because actually this means that we actually needed more money and time to finally achieve this modernization. And above 50% of the project deliver about 45% of the intended business benefits. And what are the reasons for this modernization to fail? It's actually because there is lack of documentation and knowledge of the system, wrong approach, time pressures, lack of people with relevant skills. So, what team you are you going to take that risk or not? Let's assume that we take that risk and we go to modernize our software. We need to think about what strategy are we going to take. There are many reasons of what we choose, but nevertheless, this has to do also with the management, with the budgets, with the time pressures, and such stuff. Let me tell you about some approaches. The first approach is the cold turkey. This cold turkey is actually the big bang. It's like saying, I will close my shop and I will come back after 1 year and I'm going to show you the results. So we are talking about a big bang situation, high risk and costly, because after 1 year, when you come back and you show that to the customer, they might tell you, I don't want it at all. And reduced business benefits, because you don't keep asking your business, your customer, what do you want? How do you want me to readapt the solution based on your needs? And another approach is that the wrapping duct tape, you know. We just make fixes, 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 fixes. But all these fixes on a legacy application are done with, let's say, a modern way. But you still keep the legacy application. You don't change the old code there. What are the characteristics? As little modification to legacy as possible, use of wrapper technologies with legacy adapters, lower risk and quicker results, and higher cost, complexity, and risk in the mid-long term. And at the end of the day, you don't 100% modernize your application with that. The last approach I would like to share is the gradual replacement. A component, actually, this gradual replacement has to do that, first of all, you have the intention to fully modernize your application, but you do it with a gradual integration tactic. You do it gradually by placing, all the new components with a modern way, and then changing from time to time all the remaining parts. So moving one piece at a time approach, low risk, lower cost than total transformation, than the big bang, quicker results, and lower business impact and cost of failure because you have the continuous feedback by customer. And there are some replacement techniques like Chicken Little, which is related to gateways usage, and Butterfly, which is actually related with the data access allocators. I highlight the Chicken Little because in our case, in the project I work on, we actually choose to go with the Chicken Little and technique and the gradual replacement approach. It's very important to say that when you start a modernization, it's very important to ask, do we have all the technical prerequisites prior our, our kickoff to start this modernization? So what is this all about? This is about to have some architecture governance. Are some standards in place? Or are we going to do whatever we think we can do? Technical standards, a lower level standards, I mean, in terms of source code, how we write the code, what patterns we use. Such details, I don't want to get in more detail. Of course, I have some examples below, like the build permits, which is a process we have in Chubb, and the Chubb stack, which is actually the technical standards documentation we have. UI, UX specification, so interesting, because as a company, when you want to create a solution, you want to have some standards, because if you have 100 solutions and you want to keep some, some common form, common uniformity, let's say, it's very important to have also some UI, UX standards, like the Marina design standards we have. And tools and libraries. Like Chubb UI and UIKit we have in Chubb. So you have commonly used tools where you can get them and build your solutions faster. And API gateway, you can also have as a company, before you try to start a modernization, some mechanisms to build all your APIs against them. And of course, DevOps, development operations. You need to have organized, all the part that has to do with GitHub repo, with your repositories, your pipelines, static code analysis, and such stuff. So, okay, we talk about this gradual modernization, this gradual integration method approach. What better to go with microservices? You don't choose to go with microservices because microservices is cool, is trend. You do it because it's convenient in your case. And since we are building new components from time to time, we adapt those components based on the needs of our customers. It's a very good case to use them. Okay, I'm not going to tell you what is microservice. We all know it's, it's something very standard, just because we ran out of time, of course. We know why I want to go with microservices, but I want to keep, to stay a bit here in terms of the hexagonal architecture we choose. This hexagonal architecture has to do with the layers that we built our microservices, this application, domain, service, and adapters layer. And what is the issue? For example, right now we have some adapters, okay, to use. And these adapters are SOAP adapters because our application is integrated with other applications. That other applications are still legacy, legacy to legacy, but it's okay. They are also about to be modernized. And right now we have some SOAP services to integrate with, so we have some SOAP adapters. And then it comes a new modernization era where those applications will serve REST APIs. So we're going to change only the REST adapters. By following this pattern, we actually have the ability to isolate the business logic into the service layer. We have also the adapters layer or the infrastructure. So, some build it with a name infrastructure anyway, to work on this side, on how the communication with the outward or with the resources will go. So here you can see it's not very clear, unfortunately, this mapping. I guess the presentation will be shared. If not, I have my LinkedIn, find me, and of course I can share this to you. This is actually a mapping. What we have a broker, we have some REST adapter. This REST adapter actually talks to the service through a use case, which use case is actually a domain input. And then with an output port, we talk with a persistent adapter, which persistent adapter talks with a database. So if something changes in terms of business, we only have to do work on the service layer. If something changes on if the database changes or the adapter on the outward changes from SOAP to REST, we change the REST or SOAP adapter. And regarding the front-end side, of course, there is also another trend, but in this case, it's also very convenient. If you have also many teams to collaborate, or many front-ends to build and do it one product at the end. And this is the micro-frontends. There is a very a nice approach where you can have actually like with the same philosophy, like methodology, philosophy, how to say, we use the microservices, we have also the micro front-ends, where you have the host and the remotes. And you have the ability to build them, in a way so you can actually create different things and adapt them inside your page. Like different Angular, React projects. Now, regarding micro-frontends, there are various ways to use them. We can use them with multiple repos or mono repos. The reason why we don't prefer multiple repos, it's not bad or it's not good or bad, okay? But in our case, we want to, we recognize that we want actually to get rid of the risk of the anarchy, micro-frontend anarchy. Because when you have totally different repositories for each micro-frontend, you might mix technologies, tools, frameworks, and might duplications and many things. So by going with monorepo, this encourages strategic collaboration, improves shared components usage, single version policy, increase reliability. You have one package at the end, but you can have various versions of micro-frontends inside the monorepo that you deliver. And here I have a particular tool that we use actually. This is NXDev, where you can actually visit. This generates automatically some graphs where it demonstrates how the micro front-ends are built in your case. I'm not going to describe, there are various layers that are created when you use this tool. It's okay, I have 20 seconds. Let's go to the conclusions. Let's say, conclusions. Avoid legacy to legacy modernization. Prepare your tech ground. Choose technologies as per your needs, not as per trends or whatever. Build gradually, one piece at a time, and deliver fast. So, there is no silver bullet. I'm not here today to say that this is the correct, this is the wrong, and something like that. But for sure, there is a golden rule for everything when you build. Learn legacy, because study the past if you would define the future. So it's very important to understand what is this that we want to modernize, and then we go and modernize it. Thank you very much.